objectives. At the end of the course, the user will be able to understand the general consideration about integrity, overview of data integrity. Data integrity refers to the overall completeness, accuracy, and consistency of data. Data integrity is usually imposed during the database design phase through the use of standard procedures and rules. Data integrity can be maintained through the use of various error checking methods and validation procedures. The concept of data integrity ensures that all data in a database can be traced and connected to other data, which ensures that the data is recoverable and searchable. A well-defined and well-controlled data integrity system increases stability, performance, reusability, and maintainability. Types of integrity. There are 4 types of integrity: entity integrity, referential integrity, domain integrity, user-defined integrity. Entity integrity. Entity integrity is concerned with the concept of primary keys. The rule states that every table must have its own primary key and that each has to be unique and not null. Referential integrity. This is the concept of foreign keys. The rule states that the foreign key value can be in 2 states. The first state is that the foreign key value would refer to a primary key value of another table, or it can be null. Being null could simply mean that there are no relationships or that the relationship is unknown. Domain integrity. Domain integrity deals with the validation of data in a particular table. It is enforced on the column values by restricting its data type, format, and range of possible values. User-defined integrity. User-defined integrity allows us to define specific business rules that do not fall into one of the other integrity categories. All of the integrity categories support user-defined integrity, that is, all column and table level constraints in create table, stored procedures, and triggers. Introduction to predicates. Predicates. A predicate is not simply an expression that evaluates to true or false. There is more to it. The term predicate is used to refer to an expression that determines whether something is true or false, or in other words, it makes an assertion and returns true or false based on that. The predicate is an expression of taking truth values. It may be both a single expression or any combination of numberless expressions built by using Boolean operators such as AND gate, OR gate, and NOT gate. The SQL predicates evaluates to the predicate table. P value is true and Q value is true means P and Q is true. The predicate table P value is true and Q value is false means P and Q is false. The predicate table P value is true and Q value is null or unknown means P and Q is null or unknown. To remember combination rules for these 3 truth values, it is denoted as 1 for true, 0 for false, and 1/2 for unknown, that is, it remains between true and false. The predicates are as follows: null operator, in operator, like operators, between operators, comparison operators, predicate null. An attribute, a column, a field can have the value null either because of incomplete information or because the data is not relevant. Syntax is null and its negation is not null. Example: select name from student where details is null. Predicate in. It comprises a list of values and checks if a particular value appears on this list. Syntax: in, value 1, value 2, and so on, and its negation not in, value 1, value 2, and so on. Example: select model from PC where HD in of 10, 20. Predicate between. It specifies the inclusive range to test the expression values. The range is defined by boundary expressions with AND keyword between them. Syntax: between lower limit and upper limit. Example: select name from student where rank between 1 and 5. Predicate comparison. In this, two expressions are separated by a comparison operator. There are 6 conventional comparison operators: equal to, greater than, lesser than, greater than or equal to, lesser than or equal to, not equal to. The expressions may be of character or numeric type. Syntax: A1 lesser than B1 or A1 is equal to B1 and A2 lesser than B2, etc. Example: select name from student where M1 is greater than or equal to 90 and M2 is lesser than or equal to. Triggers. A trigger is a named database object which defines some action that the database should initiate when some database-related event occurs. To concern with integrity support, integrity constraints were often implemented procedurally using triggers. Triggers deals with 3 parts. Event activates the trigger. Condition tests whether the trigger should run. Action: what happens if the trigger should run. Triggers are executed when user deals with the data manipulation commands like insert, delete, update on a table for which triggers has been created. They are automatically executed and also transparent to the users. Syntax. The general syntax of create triggers is create trigger, trigger name, before or after, insert or update or delete, on table name, for each row, trigger body. Create trigger, trigger name. This class creates a trigger with a given name. Before and after keywords specify whether the triggers fire off before or after the event takes place and it is called trigger time. Insert, update and delete keywords are used to determine the trigger event. On table name, this class identifies name of the table to which trigger is associated. For each row, this clause is used to determine whether a trigger must fire when each row gets affected. Example: the price of a product changes every day. It is important to maintain daily prices of the product. User can create a trigger to update the daily price product table when the prices of the product is updated in the product table. First, create a daily price product table and product table. Then create daily price trigger and execute it. Let's update the price of product. Once the above query is executed, the trigger fires and updates the daily price product table. Integrity rules. Introduction to integrity rules. Data integrity means data remains stable, secure, and accurate. It is maintained by internal constraints known as integrity rules. The relational model uses integrity rules to create tables that are accurate and consistent. Relational model stores data in the form of database table. Integrity rules can be applied to models in two ways. By building tables that stores information in single location. This method protects the changes in data that are automatically updated across the system and will not be redundant. Redundant means same data present in many places. By using normalization techniques to enforce constraints with domains and keys. Types of integrity rules used in data modeling are Relational integrity rule, Entity integrity rule, Referential integrity rule, Domain integrity rule, User-defined integrity rule. Types of integrity rules. There are two integrity rules associated with the relational model are Entity integrity rule, Referential integrity rule. These two rules are general rules that the user can apply to any database. It uses primary key and foreign key to maintain a relationship between tables. The referential integrity rule states that if base relation R2, that is child table, includes a foreign key Fk matching the primary key Pk of some base relation R1, that is parent table, then every value of Fk in R2 must be equal to the value of Pk in some rows of R1. Be only null, that is each column in that Fk must be null. For example, when adding a new row to a table containing Fk, the table containing the referenced Pk must have a matching value. In this table, branch number in the staff relation is a foreign key targeting the branch number attribute in the branch home relation. It should not be possible to create a staff record with branch number B002 unless there is already a record for branch number B002 in the branch relation. User should be able to create a new staff record with a null branch number to cater for the situation where a new member of staff has joined the company but has not yet been assigned to the particular branch office. The entity integrity rule states that in a base relation, primary key column values cannot be null. That is, null values are defined as empty or containing no values. A primary key is a minimal identifier that is used to identify columns uniquely. A IDMS product such as Microsoft Access automatically enforces entity integrity by prohibiting null values in the primary key fields. If we allow a null for any part of a primary key, we are implying that not all the columns are needed to distinguish between rows, which violate the definition of the primary key. Consider the following student database in order to understand the concept of primary key and null. Now, record 3 and record 5 are not distinguishable as their roll number is null and it is not possible to exactly locate one of the student as he is having a common name, class and marks with another student. Record number 3 and 5 violates the rule of primary key. Because the roll number is primary key, all the value of columns are unique, but their primary key entries are null, and this violates the integrity rule 1. So, these records are not allowed in IDMS. Domain integrity rule states that the values in a table are legal according to the physical and the logical domain definition. For instant explanation, the student ID column domain might be physical, data type numeric, length 4 characters. Logical, the range of the number between 1000 and 4999. Therefore, the field would only accept input of 4-digit number between 1000 and 4999. User-defined integrity rule. User-defined integrity rule states that users define specific business rules that do not follow other integrity rules. Business rules demands that when a specific action occurs, further actions should be triggered. For example, deletion of a record automatically writes that record to an audit table. User can define integrity rule according to business policies. All other integrity rules categories support user-defined integrity. SQL support. The following detail shows which integrity constraints comes under SQL support and which constraints does not comes under SQL support. SQL does not support type constraints. A type constraint specifies the legal values for a given type or domain and is checked during invocation of the corresponding selector. SQL does not support attribute constraints. An attribute constraint specifies the legal values for a given attribute and cannot possibly be violated if type constraints are checked. SQL does not support relational constraints. A relational constraint specifies the legal values for a given relation and is checked when the relation in question is updated. SQL does not support database constraints. A database constraint specifies the legal values for a given database and is checked when the database in question is updated. SQL integrity constraints. Integrity constraints are used to apply business rules for the database tables. Integrity constraints provide a way to ensure the changes made to the database by authorized user do not result in data consistency. The constraints available in SQL are primary key, foreign key, not null, unique, and check. Constraints can be defined in two ways. The constraints can be specified immediately after the column definition. This is called a column level definition. The constraints can be specified after all the columns are defined. This is called a table level definition. SQL primary key. Primary key defines a column or summary. In this class, we have learnt about integrity, types of integrity, various integrity rules, SQL support for integrity.